Thank you, Detlef. Yeah, so there I am. I'm going to do this. I don't know who did that. I'm going to do this. So that's me, and Detlef already stole my thunder because my real claim to fame in this room is that I was a research scholar here from 1973 to 1975 in the methodology group. I think I was number 3 in the methodology group. I saw that Detlef has the same picture. We both lifted it from the internet. I saw him lifting it from the internet. Here's another one from the internet. There's Howard Raiffa when he joined the statistics department at Harvard University. This must be around 1955, something like that. Here's a more recent one. This is 50 years later. The guy on the right is Ralph Keeney, who you'll hear from later. I'm showing this as much as anything because I think it's a good picture of Howard. Like a lot of other people, this book influenced me greatly. I remember the day, I remember where I was when I lifted this book from the library shelf and started reading it and was hugely impressed. And I've been studying decision analysis ever since, so I call that influence. What I'd like to do is talk a little bit about his ideas in this book and what has happened to them since, and where perhaps I think the promise of the book is not entirely being fulfilled. So the elements of a decision tree are alternatives, probabilities, and preference. And where do those come from? So alternatives, often they're just the creativity of the person that's solving the decision, past examples. Probabilities come from statistics, data, but also subjective probability. If we were here 30 years ago, we'd still be battling the Bayesian versus empirical battle. That battle, I think, is long gone. But preferences also come either from sort of objective reasoning or subjective reasoning. And my belief is that we are still at the early stages of accepting subjective preference as an appropriate input into decision-making, into analytical decision-making. So that's point 1 at the bottom there. Modelers have come to accept subjectivism in probabilities, but not yet in preferences. That's an assertion. Beth Fulton yesterday was talking to the point about people wanting transparency in models, and I'm going to speak to that. Detlef mentioned this book in my early years at Harvard Business School with Howard Raiffa. We wrote a few papers together. You'll be glad to know all appear in this book, so I recommend it highly. The first chapter by the 3 of us talks about descriptive, normative, and prescriptive decision-making. Descriptive is pretty obvious. You're describing how people do make decisions for better or for worse. One of our, Remo will speak to that a little later in the session. Normative decision making is where you're assuming that everybody's rational, everybody has all the information, the objectives are clear. What is the answer to that problem? Prescriptive, which is what the article was really about, is where you recognize that in decision making, you don't always have all the information. You don't always necessarily understand your objectives precisely, but you still have to do something. Detlef also mentioned the work I did on regret. And when I did that work, there was a lot of debate about whether I was saying this was a normative model. People should take account of a regret. I think descriptively, a lot of people do have regret when they make decisions and it goes wrong. But I think prescriptively, If you're the sort of person that suffers from regret when you make a decision or after having discovered the outcome, then it's appropriate to incorporate the anticipation of that regret in your decision making. It's a prescription. It's a question of what should you actually do? And Howard Raiffa would often say that. What should you actually do? At the Harvard Business School, we teach by the case method. And so every class is a problem, a managerial problem usually. And what we always ask the students, yes, I know there's incomplete information. I know you can't do all the analysis you want to do. But you've got to make a decision. What should you actually do? I said I was here in 1973. YASA was just getting started. We weren't entirely sure the Institute would last 2 years, let alone 40. So it's amazing. It's amazing for all kinds of reasons to be here 40 years later. But YASA must be doing something very, very well to be here 40 years later. But I wonder how famous we actually are. Beth also anticipated my remarks here. She said yesterday rather nicely that people are often suspicious of models, but then quote the results of economists. And economists get their views from models. So what's going on here? Why is it that economists are rich and famous and listened to throughout the land, but maybe not so much systems analysts? In finance, the capital asset pricing model has had huge impact. Again, this is born not of regret but jealousy. The economists and finance people are earning millions by giving advice off very simple models. I mean, you know, finance, CAPM, is based on mean variance optimization. You know, in the world of decision analysis, you know, we look down on mean variance. But while we're looking down on it, these guys are making a fortune. Danzig was mentioned a couple of minutes ago, or a few minutes ago. You know, linear programming had a huge impact. But has systems analysis had a huge impact? I think my conclusion is that the reason these models, or these types of models, have had such success is they actually prescribe solutions. They also are relatively, because of their elementary nature, it's possible to do sensitivity analysis and kind of understand how the inputs and how the recommendations relate to the inputs and to the preferences. So thinking of systems models, I keep standing over there, is that the problem? I have three levels of models. The first one really isn't a model, that's the real world. We have, well, the real world, I won't say any more about that. In systems analysis, a lot of the time, what we're trying to do is build a model that is as accurately represent the real world as possible. So it doesn't matter how complex it is, the measure of its value is how well it replicates the real world. Because it's so complicated, optimization is not so easy. So we tend to investigate optimal solutions by trial and error, by trying different procedures. Preference, the box on the right, is often ignored. Dr. Shevlin, yesterday when he was talking about earthquakes, he said that there were two kinds of models. One to forecast and predict when earthquakes were likely to happen. And he said an entirely different type of model is a model to say when you should announce to the world that an earthquake was coming. And you can see those are completely different models. I mean, a lot of the science would be similar, but the values in the second one are very important, because if you announce an earthquake is imminent, you're going to cause all kinds of panic and disruption. If the earthquake doesn't actually occur, that's quite a penalty. So in trying to decide whether to announce an earthquake, you have to trade off the value of saving lives by announcing this prediction versus the disruption cost if you're wrong. At the bottom level, is usually a simpler level of modeling, which is designed for optimization. We tend to talk about preference there being the objective function, often fairly simple. Dr. Romish, in his talk about energy, described a way of going from a complex systems analysis model down to a simplified model. And what he said was they generated 1,000 random scenarios. I think they were random, but anyway, 1,000 scenarios, and then treated that as a probability distribution that you can optimize over. So, I'm describing there's the real world, there's the systems analysis world, and then there's the kind of optimization model world. And my thesis is that it's the people at the bottom that are having the most impact, partly because it's simple, but partly because at the bottom we are used to putting a preference function into an optimization model. You can't optimize unless you have a preference function. But that in the middle level, we're not so good at incorporating preference. Simon Levin yesterday mentioned this budworm project that I was involved with when I was here at IASA. Here's another photograph from the Bell archives. This is the budworm crew. Buzz Holling on the left, later director of IASA. George Danzig, simplex method, you should know him, your speaker. Bill Clark, who was later a program director in his own right at IASA, now at Harvard. But this bunch got together to work on this budworm project. The study is about the forests of New Brunswick, Canada, which are at times devastated by the spruce budworm, a pest. It's certainly a pest if you're in the logging business. And until 1967, the pest was controlled by DDT, which was then outlawed. And then the question arose was how to manage this pest without using DDT, because nothing was as effective as DDT. So the ecology group, Holling and Clark, came from Canada with a complex simulation model, thing in the middle there. So in those days, one simulation run generated, a huge stack of printout of what happened to the forest over time under whatever management strategy you put in. And when Danzig showed up, he said, we need to solve this, we need to represent the simulation model as a linear programming model. Hammer looking for a nail, but still. He discovered that you couldn't actually do linear programming on this model because it was too complex, and substituted dynamic program instead. And so what we came up with was a dynamic program that replicated to a certain extent, but not exactly the simulation model. Danzig also proposed that the objective function should be the net present value of profits to the logging industry. And that's when I started to really take exception, because it seemed to me that, having worked with the ecology guys, that maximizing the net present value of the logging industry wasn't exactly what they had in mind. And they were called the ecology group, after all. And so I did an experiment, talking of experiments, whereas I came up with 20 scenarios that came out of the simulation model, and asked each member of the group to rank order those scenarios, best to worst. If you could pick a scenario that the forest could follow over the next 100 years or whatever, which one would you prefer? And they rank ordered those. This, as you can see, is the original typed version of the results. The 4 names are the members of the ecology group. The entries are the correlations. And the right-hand side is Danzig's net present value criterion. And as I expected, there was actually a negative correlation between that objective and the subjective preferences of the ecology group. The ecology group were very surprised that there was not a correlation 1 on their own preferences. So even though this group had worked together for many years, their ranking of the scenarios was not perfectly correlated. And as a result of that, I started working with Bill Clark to model the preferences of not really the group. Bill Clark was instructed to think of himself as like the Prime Minister of New Brunswick. What would a policymaker want out of this forest, trading off, the interests of the logging industry with the environment and so on and so forth. So that was a very complex exercise. One of the things we discovered was that Bill, standing in for a policymaker, was very concerned about the stability of logging profits, logging activity, not so much to help the logging companies, but because of the stability of employment. Later, I actually went to New Brunswick and talked to the real policy leaders, including the Prime Minister of New Brunswick, and I also talked to the logging companies, the CEOs of the logging companies. And I remember asking one of the CEOs what was the major uncertainty he faced. Was it the price of pulp paper? Was it the supply of wood? And he said his biggest uncertainty was government policy. The government never could make its mind up what it was going to do, and he would be really happy if they just decided something rather than dithering. And this comes back to the notion that in analytics you can keep going and going and going, but at some time you really need to stop and make a prescription, make a recommendation. So Buzz Holling eventually wrote a paper in 1978 or 79 or something like that, where he described how to make policy recommendations for environmental policy. And the paper describes basically the bottom row there. Again, in a situation where sort of that is having the most impact. So this 40 years on business, systems analysis has advanced considerably. I'm in awe of some of the models I see in the posters and by studying what IASA is doing. My colleagues who are following me to the podium are going to show you that in the last 40 years, preference analysis, the art of preference analysis has progressed considerably, but they've developed apart. And I think that in order for systems analysis to have impact, IASA has to do one thing in particular, and that is to make a concerted effort to collect the preferences and model preferences of decision makers to the same degree of detail that we do with analyzing the world in a systems analysis model, and thereby increase the rate at which systems analysis makes recommendations. Dr. Wada, who was here this morning, ended his talk by making sort of recommendations about what the world has to do to meet the water shortage. That's good stuff, and that's what Howard Raiffa would have wanted. Thank you.